Hello students, welcome back. So in this session, I'm going to show you how you can generate random numbers using Python and NumPy. And I'll try to implement three methods: linear congruential generator, middle square method, and Blum Blum Shub method. All right. So first thing you want to do is import your NumPy as NP. So come over here, import this, and run the cell. All right. Next thing. So let's start with linear congruential generator. So basically, the idea is this: in this LCG method, you start. This is the your essential. This is your formula right here. Okay, this is your core formula. And what this is saying is that x of n plus 1, which is each value, is going to be equal to a times the previous number, okay, previous value, plus c mod n. So let's work with an example. So assume your a equal to 5, c equal to 3, m equal to 16, and your seed value is 7, okay? Your x0 equal to 7. Anytime when you come across these types of formulas, you always have to specify your initial values, okay? So this is your seed value. So let's start with this thing. Okay, so my x0 is 7. All right, that's given to that's basically we started with this thing. So your x1, okay, x1 is going to, according to this formula, is going to be equal to a multiply by x0, right? Plus, let me make this thing 0 a little clear, plus your c, all right, plus c, and then mod m. All right, now you substitute your values. So what is your A? Well, A, I'm picking up 5. By the way, I'm just picked up these 5. I could have picked up any numbers. I'm just picking up A, 5, C equal to 3. So this is going to become 5 multiply by my x0. What is my x0? 7, right? It is 7. So 5 times 7 plus C. What is my C? Well, I picked up C as 3. So this is going to become 3. And then mod right here, mod your 16, right? M is 16. And so this, if you solve this equation, this one, this will come out to be 35 or 38, sorry. 38 mod 16. Now, if you remember from your maths class that anytime when you do some number mod 16 or mod any number, basically you're dividing this number by that number and you're finding the remainder. So when you divide 38 by 16, your remainder is going to be 6. So that's what that is. That's your remainder. Okay, and that's what I'm doing over here. This actually is doing calculation right there. And likewise, you can calculate x2. Okay, so I'll just show you over here. Your x2 is going to be 5. Okay, your a multiply by previous value. So your x2 is going to be a, okay, multiply by x1. All right, that's my formula, right? This is my formula right there. All right, x1 plus c. All right, and then mod 6 m, right? So now you can substitute your a, x1, c, and m in there. We know our x1, right? X1 is 6 right there. So by substituting these numbers in there, you get this expression right there. So this is your expression right there, okay? And then the answer will come out to be 1. Okay, same thing, you can calculate your x3 likewise, okay? You can calculate your x4 and so on and so forth. So you will get these random numbers. So your random numbers would be 7, right? That was your first random number. The second random number was 6, which is your 6. So write down 6 over there, and that's what that is: 7, 6. And then the next random number was 1 right there. So 1, and then after that it was 8, and then 8, and then it was 11, and then 11. So this is how you get these random numbers with their seed 7 in the beginning. Okay, so let's try to implement this in Python. All right, so come over here, scroll down, copy this code, come over here and paste this thing and run this. And as you can see, I'm using exactly same seed. Okay, my seed is right there. Okay, seed, I'm basically specifying 7. And as I specify my seed 7, I'm saying generate me 10 numbers, and it generates exactly same numbers: 7, 6, 1, 8, 11, and so on and so forth. So this is the logic basically that's happening. You create a list. Okay, this list is it starts with a seed value inside, and then inside the list, inside this numbers list, you keep appending more numbers. And what this number is basically is exactly the same thing I just showed you. That formula: a multiplied by x plus c mod m right there. This is the notation for mod m. So this is fine as long as your numbers are okay up to 10,000, even 100,000 random numbers. What if you want to generate 1 million random numbers? Okay, so you want a high speed, you want a faster way, and that's where your NumPy comes and helps you out. So you can implement the same thing in NumPy, and if you want to generate, let's say, 1 million plus random numbers, your NumPy would be faster. So this function is essentially same as the top one. The only difference is that I'm using this np.empty over here, and my every all my computation is done through NumPy. So when you run this, it also generates the same random numbers. Okay. All right, now let's focus on middle square method. So middle square method, the idea is basically this, that you start with a number. Okay, so start with the seed. All right, start with the seed, square the numbers, take the middle digit as the next number, and keep doing this thing. Okay, keep repeating the same process. So let's say my seed is 5735. So my first random number is going to be 5735. All right, my next one, square of 5735 is this number right here. Now you take the middle four digits, which is 8902. So 8902 is my middle four digits. Square the number again, and then you come across another number, and then you take the next four digits. Okay, so this is going to be 8902. Square the number, take the next middle four digits, and you just keep repeating the process. Okay, so let's implement this in Python, and copy, paste over here, and let me just create some few more cells. Come down, paste it. So basically, that's what I'm doing. I'm squaring every number, each number I get. Okay, I square the 5735, and then I take the middle four digits. Is 8902. So that's my next number. Then I square 8902, square it, take the middle four digits. Is 2456, and you keep repeating the same process. And then basically, this is the logic right here. That's doing that. And then I'm also taking right now the way you're taking the middle four digits, you use this slicing right here. So this is your slicing. Okay, so I'm taking my square numbers and I'm slicing this, the middle four digits, and then at the end I return my numbers. All right, so this is one way you can implement your Blum Blum Shub method. Sorry, middle square method. Then there's a Blum Blum Shub method. Sounds kind of interesting. Blum Blum Shub method. Okay, so in this method, basically, this is what you do. You start with x of n plus 1. Okay, so here, this is your algorithm. This is how you start. All right, and you pick up your p and q. Now remember, try to pick up p and q as large numbers. Okay, the larger the number is, better your randomness and randomness is going to be. So in this case, let's say you start with p equal to 7. I'm just picking up small values just to show for demonstration purposes. So if my p equal to 7 and q equal to 11, then according to this formula, my m is going to be p times q. So my m is going to be 77. Okay, start with seed 5, x0 equal to 5. So that's my first random number, 5. All right, my next random number is going to be x1, right? x1 equal to, I'm going to use this formula by the way. x1 is going to be equal to x0 square mod m, right? So capital M is 77, mod 77. So this is going to become x0 is my 5, right? It is 5. So this is going to become 5 square mod 77, right? Mod 77. And the answer is 25. Okay, because 25 mod 77, 25 divided by 77, the remainder is still 25. That's your answer, 25. So this is how you come across 25 right there. So the first random number is 5, the next random number is 25. All right, now do the same thing. Okay, you take x2, you take the previous value, which is 25, square it, and then take mod 77, and the answer would be 9. You get 9. And then same thing with x3. This is how you basically iterate through each and every number like this. Okay, then let's try to implement this now. Let me remove this. All right, let's try to implement this. So Control A, Control C, come over here, paste it. All right, so basically, this is the same logic. I'm calculating my m right there. I'm creating a empty set of list. Okay, I'm creating a 10 numbers in it. Then my x is equal to seed, my initial value. What is my initial value? I'm starting with 5. All right. Okay. And then basically, I'm just doing what I just showed you a minute ago. I'm squaring the numbers, taking mod of that, and I'm putting that inside my numbers right here. Okay. All right. And then I run this code, and it generates exactly the same numbers right here. So this is the implementation of your Blum Blum Shub method. All right, gentlemen. Thank you.